Hello, ladies and gentlemen, and welcome to this live stream. My name is Madde. I am a software developer at 1337, but today I'm here to bring you some knowledge. I hope that you are all well and safe, and I hope that you're healthy and that your loved ones are healthy, because this year it has been quite crazy, and it's okay to feel overwhelmed, right? I know that most of us do from time to time. So before we start, I want to be a bit honest with you. This week has been pretty rough for me. It's my fourth week of working from home, and it's starting to take a toll on me. So, first week we were all like, oh, we're in this together, we're gonna sort it out, and we're gonna do the best we can, And the second week we were still feeling the, positivity and everything, and by the third week, it starts to feel a bit lonely, and you feel that you haven't met people that much that you used to. And on Monday, I woke up and I just felt no motivation, no purpose really, and kind of felt very disconnected from everything. You know what I mean? And well, I know it's just a phase and it will get better soon. It's a roller coaster, and I already feel better just by being here together with you, even though I can't see you or anything. It just feels nice to know that there are people out there and that we're here together, right? And I'm so delighted that we do these remote code lunches, because I know that there are people out there probably feeling the same. And by doing this, we don't only share knowledge, which is a great thing, but we also make people feel a little less disconnected. And that makes me just so proud of being part of this. So today we'll deep dive into self-contained systems, microservices, and microfrontings. And with me, I have an expert on the subject, which is my dear colleague, Per Ökvist. So hi, Per. How are you?
Hi, I'm good during the circumstances.
Yeah. You've also been working remotely for the last couple of weeks?
Yeah, this is also my fourth week, but the sun is shining and that is helping a lot. So
that's true. Maybe you can work outside.
And that have crossed my mind a few times.
So before we start with your session, I want the audience to get to know you a little bit better. Last week, when we had a code lunch with Shiga and Clement, we did 2 truths and a lie. So I figured we'd do the same with you.
Okay.
So, Per, can you tell me 2 true things about yourself and 1 lie, and then we'll figure out after the session which one was the false thing.
Okay, I could give you 3 claims that is often heard in this household. Where 2 are true and 1 is false. And that is my wife thinks I have too many watches, too many board games, too many records.
Okay, so you are a person who collects things. Which one?
Hobbies tends to be taking space.
Yeah, but now you will be talking about the self-contained systems. And as usual, if you in the audience have any questions, please post them into the chat and I will forward them to Per after the session. But with that being said, I leave the word to you, Per.
Okay, so let's head over to the presentation, and I might correct you a bit because I've prior talked only about self-contained systems, but today we're going to talk about that in a slightly different manner, but coming from a performance perspective. So the story here is that a few weeks back, we at 1337 held an open space here in Malmö, southern Sweden, focusing on all things performance. So there I gave a talk as a foundation for the open space format, trying to inspire things about performance, both from a team perspective and a technical perspective. And during the last year, I have been able to work with clients around performance and also attending conferences in the performance community. That was something that was new to me. So what I'm going to give today is a quite broad topic about performance and collaboration that touches a lot of different things. So I think this is well suited for lunching. So There is not going to be any brain-burning things. You could just sit back and relax and nod or pay attention when something new appears. So let's start and see what we're going to talk about. We have just talked about the introduction, the different kinds of performance that we might try to cover. But we're going to talk about JavaScript. We're going to talk about metrics and KPIs for measuring performance. We're going to touch on the subject of scaling, and then we're going to head over to the more soft topic of organizational performance and try to tie everything together. So let's just go back and see what is the service responsibility or the server responsibility and keep it at a really high level. So basically what we often have in our application is some persistence layer, and the persistence layer is our source of truth. Then we introduce the server where the application might reside partially, and that is in academic terms the protector of invariance, meaning implementing business rule upon the given state. It's also the entry point for web application, of course, serving documents and resources over HTTP, if not a gRPC or something else. And then you have the client. So today we're going to focus on the perspective of the whole journey from the client into our application and see how that affects performance, and later then how it affects collaboration. So it might start that you one day in your Twitter flow or somewhere else on Reddit, or a colleague sends you something, and if you're not working closely to the front end, it might come to news to you that someone states there is a cost of JavaScript. And some articles you might be sent might look something like this. So what do they mean of cost of JavaScript, and how do this affect you if you're not working that closely to the client? That's something we should explore. So if we go and have a look at some other presentations on the topic using the web archive, we could see that performance in timing in desktop and mobile application throughout the web is not as fast as expected. So you see here that in the 50th percentile have something like 3.4 seconds on mobile, and that is main thread processing time. So if we go further and see the real cost of the JavaScript is frameworks and adding dependencies, and they might also imply later execution of your application and your KPIs. So this is something we need to bear in mind if we want to have a fast conversion, if we're selling something, or having click-through rate or something else, to balance these things right. So is this something that involves the server? So we need to introduce some performance metrics and having an overview that there are a lot of KPIs to keep track of. So today we're going to mainly focus on two of these. But just to know that there are a lot of different KPIs in measuring performance that you need to keep in mind. So we're going to start from the server perspective and talk about the first one. So time to first byte. That is clearly something that involves the server, right? So here is the journey from the client to the servers and back again. And of course, this involves firstly the client, the device, and then over the network, and then later over into the server execution in the data center. And probably we are going to rehide some state or query. We need to do some basic server execution and then network again. So this is, of course, hiding a lot of things, but to give you a picture of what's going on. And every step here is affected with a cost, because the KPI we are measuring is when do we get the first byte back from the server. Now you might start thinking, saying like, this is clearly something that has to do with server-side rendering and client-side rendering. If I start to template a lot of things on the client, I clearly get a fast time to first byte, because I could display something and everything lazily is templated on top of that. Keep that question aside as we move on. So it's not as simple as that. So one of the prominent people in the performance community, Harry Roberts, that has visited us here in Sweden recently, have a quote: "While a good time to first byte doesn't necessarily mean you have a fast site, the opposite, having a bad time to first byte, certainly guarantees you have a slow performance." So what could he mean here? The first byte is not that important for the end user, but it's still a measurement if it's bad, that you have some latency or cost on the server that doesn't respond with the first document. So as a developer, there is a standard that you could chime into. So from the server side, you could now send a key value pair called server timing, and that standard is then collected by Chromium DevTools. So now you could have buckets for server performance in your response, so you get a waterfall on the client, including your steps of choice on the server. So here you could put queries, you could put serialization or some other compute intense thing to measure what's going on. So here you see an example, and since it's just key value, you could make up your own bucket. So here you have data, markup, and misses. So this is something you could start use to introduce the server perspective in performance measuring that often occurs in the client. But let's take a more valuable KPI as an example: time to interactive, when your user could actually do the action they want, or basically one of the actions you want them to do. So in e-commerce, that is, of course, interacting with the cart, buying things or convert things. In ads, that is click through, and in a different application, it might be to do the main use case in that scenario. So let's look at the same loop here and see how that affects that KPI. We'll still have the network and the server execution and possible DB queries and the whole application execution on the server and the network back. That is the time to first byte metric. But when we then receive resources at the client, there is a lot of going on. And if you're not a strict front-end developer or day-to-day do things at the front end, you might not have insight in what's going on. So loading script and client resources and parsing JavaScript and compiling it, executing it, update the DOM has implications. Of course, they have mainly implications on the KPI we're talking about, time to interactive. So if you lazily load and renders your cart, your product, your buy button and things like that, and you have large frameworks, resources on different domains, wrong header tag strategies and things like that, your client cannot convert or execute the main action in a timely fashion. And this will affect your business more than you might believe. So this KPI has a lot of more value than time to first byte. And this is also something that the server could take part in. So we're back to this question. Okay, so time to first byte is easily changed between client-side rendering and server-side rendering, how fast the server could send any bytes over the wire. So the smaller footprint, the better. But now you say that everything that goes on the client and JavaScript compilation and parsing has a cost and an impact. How should I balance these things out? And how could the server aid in this KPI instead? So that is what we're going to have a look at. But first, often when we talk about performance in a way that includes what we refer to that as a backend, performance often has something to do with scaling. So let's go through a few things that is related to performance and scaling, just to get that out of the way and see how much do it actually have to do with these KPIs. So scaling basically is if you have one server or one node, as we call it here, and you share the same persistence layer, you could scale your execution. This means that you still have the same dependency on the database, so the database performance is the same bottleneck for both. But then you're splitting up things like application execution, deserialization, and things that goes on in your application framework. So there are a few benefits, but still you see a pattern that the thing that scales together with these two nodes is the persistence layer. So you're basically not scaling that much. And then if you add something in front, so you could load balance between these two nodes, you see this diamond shape starting to appear that you scale across, but there are 2 points here. So the load balancer, of course, redirects traffic to each node, but the persistence layer is probably hit an equal number as before. So moving forward, this also applies if you introduce distributed caching. So 2 nodes sharing the same Redis, it's Redis that scales. It's only your application execution and runtime that is now distributed. So the same diamond appears yet again. But if we go even further, you could start partitioning your data. This becomes more interesting because now you have actually silos where node 1 and partition 1 goes together, and you have benefits, and you could scale your persistence layer to suit that partition's need. And of course, they will all go through a central point that is some form of load balancer in the journey into the server. But this also introduced that the load balancer, or the gateway in this case, needs to be partition aware to be able to route traffic to the node owning the correct data. And this is a picture of the same thing I just said, how the load balancer or gateway needs to know where to go. But then you could name the gateway, in this case, not the load balancer, and saying in these web scenarios that we're talking about, there is often CDN in places that we use. Then we have this central place collecting things from node 1 and node 2, basically reversing the diamond when we talked about Redis, placing the cache in front of the node. And now the CDN is the place where we might scale in form of caching. That might be a better strategy for some web scenarios because the CDN is closer to the client and much more performant execution-wise. But we're going to have a look at what to put in the CDN and how to utilize web caching in this scenario. But then we could move into more advanced scenarios, saying that if we have some form of reactive architecture where nodes react to ongoing changes of persistence from the outside world or some other eventing model, we could utilize the same strategy. Instead of the CDN pulling resources from different nodes, we could now push things out to CDN. And we're going to have a look at that as well. So this means that we could react when we have changes of some form of state and push a resource representing that state in a ready manner to the CDN to, of course, gain more performance and also decrease the work of the node because it's just utilized when changed. So if we flatten this picture, now name what I have said, like load balancers has a place, CDNs has a place, gateways, and look at these 3 different parts, saying that we have a client and we have a CDN and we place that in a bucket we call edge. And then you have the server and the persistence, and that might be at some cloud provider or a data center that you own or something of that fashion. So now we have these 3 lanes. So we're going to look at these lanes and see how a few things affect them. And HTTP2 is often coined as a savior that you could hide behind it, saying that if I use HTTP2, I could be a bit sloppier with some kind of performance things because this adds up. But this is, of course, in some part true. Let's look at about a few things that might not be well known about HTTP2 if you're going to go for really fast performance. So let's say that you have a scenario when you are striving for super performance and you are looking into network speed from client to server and investigating possible bottlenecks and using HTTP2. HTTP2 has this great feature called reprioritization, meaning that the client should be able to send a request for multiple resources on the same host and then change its mind in what order they need those resources to be really performant. And this is an implementation detail of HTTP2. And sadly, this implementation affects a lot of parts in our journey from client to server. So first you have your browser. Each browser might have a different implementation of HTTP2, meaning that it could be super performance in reprioritization or other things, or not so. So you might get different results testing your application in different browser just through network traffic. And then if you utilize any kind of CDN, you have yet another implementation here, that your CDN provider needs to have a fast implementation of HTTP2 as well. And then entering the data center, the load balancer as well needs to support this. So any of these 3 implementations or more, of course, affects your performance if you're measuring purely network traffic. And the sad state is that there are a few browsers that is not that performance, and there is a lot of minor CDN providers that might not have the best implementation. And that this is not something that might affect your application, but since we're talking about performance, it's worth knowing that if you're really going for it, it might differ. So these big 3s, Cloudflare, Fastly, and Akamai, have a good implementation of HTTP2. The sad news that I've caught is that mainly all data centers and cloud providers, load balancers, might not have the best implementation. So there are bottlenecks for sure in the journey between data center and the client in this aspect. So let's revisit Edge and see, we have talked about CDN and some web caching. There is also a lot of work going on there in the community now called Edge workers, moving workloads and middleware to the edge. So today, a few of the big CDN providers allow you to write some form of middleware at the edge tier. So within your CDN, you could affect traffic, implementing things closer to the client using mainly JavaScript for now. This means that the CDN provider probably executes the V8 engine or running some form of JavaScript engine to execute your custom code, and you could implement some form of middleware security or other caching layers and parsing functions at the edge. But the problem with JavaScript still resides. So the costs when running V8 and parsing and compiling JavaScript is also a case here. So if you go for this, there are a few issues, but it's still better. But what's going on with edge workers? So in the community, we have WebAssembly as well. So a few of the CDN vendors is now looking in executing cloud workers using WebAssembly, still running some form of engine like V8, but now you have a pre-compiled set of middleware, meaning that you now could execute WebAssembly more efficiently than JavaScript in some scenarios and use some heavy computing or AI algorithms or image things at the edge. And of course, at the client, JavaScript is the predominant language and implementation for that. But moving forward, we're also going to see that WebAssembly could polyfill JavaScript in some areas where it's not that performance. And then we gain performance at the client. And if edge workers is also in place, we might also be able to reuse some algorithms between the edge and the client. So this, of course, is going to affect performance of certain client applications in the future. So WebAssembly is a really interesting space to have a look at. And one quote that I came across and heard at the conference is this, and this is by one of the founders of Docker, that states that if WebAssembly and WebAssembly interfaces have existed back in 2008, that might instead have been the abstraction that would be so significant that we might not have Docker. So if you read something out there saying that WebAssembly is a new Flash or Silverlight and stuff like that, pay attention. We are not yet seen nearly what WebAssembly could mean, both for performance and web development and application developments in general. So please pay attention to that space. A lot of interesting things moving forward. So Then you might also have read that edge is quite a buzzword, saying that more and more things is targeting the edge. And as I said before, machine learning things are moving closer and closer to the client, and the client could be both you as end user or something, or more IoT perspective. And we see orchestrators like Kubernetes spanning out to the edge, of course, meaning better performance for the end user. And we have runtimes on top of that, like DAppR, that is also targeting the edge. So a lot of things is happening, moving closer to the client, that of course then means better performance for the clients. But if we take a step back and say, okay, now we have all these things around edge going on, we have WebAssembly, it's worth just noting and go through that HTTP caching is still important in some of these scenarios. So if you're not familiar with what kind of operations that are idempotent or good for caching or using e-tags in HTTP, please go back and utilize HTTP in a correct fashion. This is, of course, even more important if you place a CDN and having some web caching strategies in front of your servers. So we're not going to go through this, but just heads up, HTTP is still around, and in these scenarios have quite a lot of implications if used correctly. So please use e-tags, please use the correct API for your needs. So to sum this up, I just try to collect this under the term I call readiness. So having resources as ready as possible for the client, as close to the client as possible, of course affects client performance. So if we go back and look at the persistence server and CDN and client scenario, we could now see what we could do. So from a persistence level, have read optimized views, or if you use some eventing model, having ready projections, meaning that aggregate on queries is not that good. Have data as ready as possible, then you have better performance from a persistence layer. And of course, introduce caching at this level if you see that it fits as well. Going then to the server, when you have reached the persistence, have responded with the state that you want, you of course have the hosting. And with the hosting and location, I mean DNS lookups costs as well. So the lesser you have of different hosts from your client application, the faster it's going to be with those lookups. So hosting and location and geographic closeness to the client is of course important. Then you have everything that we're not talking about here in the application runtime. How fast is your runtime? What language are you in? Could you have effective I/O, minimal I/O, of course, and execution timing? And that's a whole different topic, language and server architecture to server architecture. Then we enter into this with server rendering. Having a ready resource means that if you're presenting content or having not that much behavior, it might be a good fit to render things at the server, having the server CPU taking that hit and in a cacheable manner serving the client a ready document for just placing in the DOM instead of parsing and executing JavaScript. And then, of course, on top of that, honor HTTP caching, use HTTP2. And then when you move out to the CDN, here you have the HTTP caching in place. The more rendered content you have, the better for some scenarios. Pay attention that the CDN actually supports HTTP2 or it's turned on. And if you look to the left here, that is more a push-based model. If you, from the server, push out static resources to CDN, then you might have an even better caching strategy, because now you might be able to infinite cache resources at the CDN and push them on changes from the server. This will, of course, give you great performance, but there are a few patterns at the server when you change things that you need to re-render resources. And of course, on top of that, you could move algorithms and middleware out to edge workers and be even closer to the client. And that now gives the client the best possible scenario from a server perspective to then add its own client architecture upon. So that was a lot about JavaScript behind the scenes, KPIs, what should we measure? Please have a look at all the KPIs and try to measure your application, introducing performance budgets and kinds like that. And from a server perspective, performance and scaling is not the only thing around. The server could take part in more parts of the web application. So now when we have a foundation of a lot of moving parts, how could we bring that in and shoehorn organizational performance on top of this technology? So organizational performance, if you have been looking around, you might have come across a few resources, and mainly the book Accelerate comes to mind when you're talking of performance. And Accelerate have been around for quite some time, have rave reviews, but also now have some other takes. But if you look here, you will find a different set of KPIs that I mainly call some form of due diligence. So if you go into a new project or starting something, you could go through these KPIs and get a feel how the feedback loop for that application have for shape. So this is basically lead time. How long does it take from having an actual request of a new feature for the feature to be able to get feedback from a real user? That is the lead time of innovation in this case. Deployment frequency is how often is this organization capable of delivering the new features or updates to this application. And mean time to restore is if something fails, how fast could we respond and mitigate that problem? And then, of course, how often do things fail? If you measure these KPIs, you get a feel of how mature the developments and feedback cycle, both from requirements, but mainly from CI/CD perspective, how mature that team or that organization is around developing software that could change and get new feedback. So it's, of course, good KPIs. But I would advise you to move forward and might pick up another book that is closer to team structure and DevOps culture that is called Team Topologies. And this book has a few other things that are interesting, that is not that clear KPIs, but they are mentioning that we need to have a team-first software architecture and organizing both our technical architecture and our teams in alignment to get better performance as a team. So real gains in performance can often be achieved by adopting designs to a designated model. So you often see, if you have a large team, that onboarding a new team member, for example, creates kind of a lot of knowledge gaps. So the easier domain or the easier scope you have within your team, the easier it becomes to be an expert in that domain. And this, of course, will affect performance and quality. So how could we have ended up in the situation that we are now, where some client aspects in introducing frameworks and JavaScript and the total application performance looks as the numbers I shown you before? And the culture in many organizations still resides to the left here, where we cater through specialist teams. In the olden days, or the current days for some, you might be familiar with having an ops team or a DBA team, you have a backend team, and you have a front-end team. Then you have teams aligned with technical specialization, and you have a lot of handover and technical domains instead. And that, of course, affects decisions made purely by the front-end team might not be that connected to back-end performance. So specialist teams could be more service-oriented, as we see to the far left here, that the backend have a few capabilities, but the front end is still monolithic. And if we divide this into teams, you have smaller backend teams being experts around capabilities or a certain form of technology, and then you integrate through the front-end team. And then you could get these performance divides, that the front-end team is using framework X and the backend team is optimizing for another performance. You could still have specialist teams in more monolithic silos, and still have this back-end and front-end divide, and the right part of specialist team is the monolithic architecture just divided in back-end and front-end. And these divides is affecting performance because you have different KPIs, collaboration issues, and you might have technical decisions residing in each part that affects performance. But if you instead focus on organizational teams having what we could call positive silos, you should organize around things that caters toward the organization and then become experts in that organizational boundary, removing technical things. You could still have what you call a cross-functional team, but have some team members that are more catered to the front end than back end, but the collaboration is still around some organizational capability. And this could also be in a monolithic structure or in a more product or silo or what we could call vertical architecture that we see in the organization. And these kinds of alignments, of course, will affect performance. If you align with the wrong organizational boundary, that will hurt. If you're organized in specialist technical teams, that might be right for some more technical organizations, but that will be a lot of handover and mismatches around performance. So getting a new feature out when you're passing through multiple teams, release trains and things like that is not good for the feedback loop or the performance overall. So good boundaries minimize cognitive load is easy quote from the team topologies book. So think about the team you're currently working in and see, do you feel that you have the expertise and the domain you're working with within your team easily fit in your mind? Or is onboarding or describing what you do hard? So would it be efficient to minimize that cognitive load in slicing that up using some strategy? And now we come into how do I found these boundaries? And there is a lot of things in our community that might see design as a negative thing, as a misunderstanding. I would strongly advise you to take a step back and do some design. And here we have 3 process models or workshop models around information systems that you could have a look at, or we might even come back to that in a future session. It's domain modeling, event storming, and event modeling that you could have a look into to collaborate and get the same sense of the big picture and do some design before implementing. And this could, of course, aid you to find the boundaries where it might be good to organize around or develop more self-contained or services. So let's talk a bit more about collaboration. So if I say that multiple teams with less cognitive load and slicing up things might be good, we still have the hardest part in our industry, and that's collaboration. Talking between aspects of humans, meetings, and things like that is still a big part of our industry and one of the hardest parts. So how could we get something beneficial out of all this? So multiple teams and the services, integration-wise, act the same way if we really trivialize the thing. So integration events in an async manner between the service foo and bar is the same as if we scale it up and say team 1 and team 2 should have some form of async communication. And this slide could be a whole presentation in itself, how to integrate processes and replicate data and things like that between teams. But when you find the correct boundaries and minimize the border between those, it becomes quite clear how efficient it could be if you have 2 good boundaries, where it might be, if you're really lucky, a few events that just come across between those teams. So if they collaborate in this manner, they might still be developing the same application as a whole. So how could we collaborate around that? And now we're entering what Madde talked about prior, this self-contained system that caters more to a composition strategy. So to be able to form a system of systems, we need to compose our system. And we have two options here. We could compose server-side, or we could compose client-side. And of course, we could mix those together. So let's see if we could use the same divisions from before to explain a simple scenario of composition. So here we have an example in server-side inclusion, server-side composition, using a standard called ESI. And this is mainly from the Akamai world, but supported with all big CDNs or varnished-based CDNs. So now we have, from the server, the blue box is serving a page, and the orange box is some form of component. We could call it a fragment. And then we have the edge understanding these markups that we could include A and B, so the result will be a complete page with A and B in it. And of course, now A and B could come from different teams. So this is one strategy that the CDN or the edge could aid us in composition of components over pages. And of course, we could use client-side inclusion, in this case, include, to basically do the same, but do it on the client. And when we move to the client, we could now implement different lazy strategies to say, is this in the viewport? Is it below the fold? Should I load this when the user scrolls? And you could combine server-side and client inclusion. And of course, the main takeaway here is that you now could have components and pages written by different teams and having strategies to form one application between teams. And a few of these things comes from another buzzword with microfrontends, where we could give an example that you're actually slicing things at a component level. So in this picture, we have a Lambda with its own state store or persistence that just exposes a web component. And that web component could now be composed into a page with some other services owning the page. So if we go back and look at these two strategies that we just saw, the server-side inclusion and the client-side inclusion, this is basically the same thing, but at a team level, saying team owns feature slices that is deployed in a manner that the team see fits. But you could slice this as granular that you want, but so it has a correlation with microfrontends. And in the examples we have talked about here, using CDNs or using include, is just a few things that could aid you in collaboration or microfrontend. So if you're interested in this topic and having more perspective and more implementation details, there is a book in the works called Microfrontend in Action that I'd advise you to take a look at, that has a more broader, flexible range, and of course go through some of the performance penalties or benefits in different strategies. And if we try to bring this all together, we have mentioned this self-contained system. So let's take an e-commerce site as an example. Now we could see that we could form these vertical teams that uses composition to form the end user experience. And here each team could work with their own KPIs, their own performance budgets, and their own performance strategies, saying that the product details page is much, much more close to good performance for conversion than our Q&A team or support team. So you could have different strategies within different teams, different approaches to architecture, and have as few touch points between teams as possible, being agile where the business see fit. So you could rearrange and say, we're doing a major push and investment in checkout instead of support, and there are no release trains between these teams. So to find out about self-contained systems, if you haven't heard my prior talk, please visit selfcontainedSystemsArchitecture.org to see what the differences between service-oriented or like microservices and this self-contained systems world really is. So let's try to for closing, give an example where we bring all this together from a technical perspective. So let's say that we go back to the e-commerce example. And now we have this orange box being some form of orchestrator. In this case, it's Service Fabric, it could be Kubernetes, it could be some higher level thing. And here we deploy a few straight web products, and we could organize team around them. And together they go through a gateway, and that gateway could have support for partitions or just some form of strategy in routing this internally. You could have ESI support as a middleware for development experience. And outside your orchestrator, you have some form of more commercial gateway, and on top of that, a CDN. Now you could bring all the key parts I have talked about into an example scenario where you utilize the edge, the CDN, you have these aspects of both a custom gateway and some commercial products where HTTP2 might have and not have benefits or problems. And then you bring in the collaboration parts with different teams and different KPIs, so you could divide into different strategies and feedback loops for each team. And with that, I hope you had a good lunch, and thanks for tuning in. So thank you.
Thank you so much, Per, for the session. It was super interesting. As for you in the audience, we would love to hear your opinion on the session. So if you want to, you can vote on poll.1337co.de. That's poll.1337co.de. And we won't present the results here, but it's very valuable feedback for us to have. So I have a question for you, Per. I know that you have been trying to implement this at your assignment, right?
Yeah.
How has that? Can you tell me the biggest struggle that you had, or do you have some advice for us?
To keep it blunt, people is the worst. So the technical part here is more straightforward in this example than you might believe. So if you just compare this to when we end this session, trying to build a super simple website on your own, and you then just have a folder called product details and a folder called checkout, and then you serve different HTML resources. Instead, just think of that these folders are distributed. They are something else on the network. That's basically it from that perspective. Then you could use composition or not. It's just a routing mechanism saying that when you go to /products, you end up in a different application than if you go to /checkout. And you have the same routes if you do this locally. This is just distributing those folders to keep it light. So technically, doing simple composition is simple, but having multiple teams changing, having an organization aligned with stakeholders and domain experts, finding the right boundaries and collaborating is much harder than the technical part of this. So if you find these things interesting, design is going to be crucial, and a lot of things in our community or line of work is grassroots movement from dev department, and this is yet another thing that couldn't be kind of tricky if you try to push it only from a technical perspective, because the real benefits here is organizational. So a few of these things needs to have much stronger backing in a larger picture to be really beneficial.
Was it hard convincing the organization to walk this path?
In one of the cases we're talking about here, it's not really about convincing. The current CTO were looking at some of these benefits in having some heuristic to maybe isolate the third-party tool into one team and focusing on a certain capability in another team. So it was quite an easy fit and more a problem solution to given problem that took this form. So in this case, we actually started with 2 teams and a a scenario saying that we should divide this component or this responsibility within an organization. And then we saw that we have more fits that we could form smaller teams with their own product owner or domain expert just catering to that. So if you look at mainly support and QA and things like that in an e-commerce site, it might be slicing the organization that is really well suited to have an application just cater to that and then marry that into the whole customer experience. So it's Lego all over.
Yeah. So did it start out as a grassroots movement for you?
No, in this case, there were some service orientation that it was more aligned with technical capabilities. And then this strategy formed from a CTO level that we might want to develop a certain capability isolated. And when we had a look at that, we had a few options saying there might be more building blocks that would be beneficial to be its own deployment unit or team, and then we need to compose a few basic things. So in the e-commerce scenario, a few of these things are mainly components in the header saying if you click customer support, you go to a different site having the same header but different content. So the integration part could be easy if you're a content-driven organization.
Okay. Well, we actually don't have any more questions today. Seems like we are all full of knowledge. So I thought about your lie that you presented in the beginning, and I think that you do not collect watches. You don't strike me as a watch person. Am I right?
You are right, but now I'm curious.
Why I could tell it?
Yeah, is it because you saw this?
Well, no. No, but I know that you like board games, so that one was given. As for records, I think that someone who doesn't collect records doesn't call them records. They would just say CDs or something.
You applied psychology to this. Cheat.
I'm a cheater. No, I'm not. But thank you once again, Per, and thank you to all of you who participated. It's been great, and I feel a little less disconnected now, so I like that. And coming up for you next week is no other than Kelvin Henney, a software developer, independent consultant, and the author of 97 Things Every Java Developer Should Know. And he will talk about lean code with us. So be there or be square. And well, that's all for us today. And I wish that you all have a great day. And I'll see you on next Wednesday at noon. Bye-bye.
Cheers.